Hello, youngings. Back again. Same teacher, different material. Mrs. Long coming at you here with simplifying radicals. So, with simplifying radicals, it's very important that we know our list of perfect squares. A perfect square is the product of any number and itself. So, in other words, if we were going to fill out this box, all we have to do is take 1 and multiply it by itself. 1 times 1 is 1. And 2 times 2 is 2. And I'm going to go ahead and fill this out because I know my perfect squares by heart. So I'm sorry, that's 4, not 2. Just kidding. I do know them by heart, I swear. 3 times 3 is 9. 4 times 4 is 16. 25, 36, 49, 64, 81, 100, 121, my favorite number. 144, 169. I easily remember 13 and 14 because 13 is 169 and 14 is 196. Those numbers switched. And then 225 for 15 times 15. I highly recommend that you memorize these numbers the way that I have. Don't mess that one up like I did, so that you're able to write them down on your quiz or test or anything like that when it comes time to be using them. All right, so this do now, we're going to investigate talking about radicals, otherwise known as square roots. You can take square roots of perfect squares very easily. So 2 squared is 4, which means the square root of 4 is 2. And this would be times the square root of 9, which is 3, and that's going to give us 6. Okay, I did that separately because this wanted the square root times a different square root. Now over here, 4 times 9 are both underneath the radical, so I have to do the multiplication first in this case. So 4 times 9 is 36, and it stays underneath the radical. But then 36 is a perfect square, so we can take the square root of 36 and get 6. And again, for C, the square root of 36 is 6. So note that we got the same value for all 3 of these things, even though they were written completely differently. Try D, E, and F on your own, and give me a sentence that explains what I just said. In the meantime, I'm going to move on talking about listing factors of the following numbers. So, listing factors, I'm going to show you what I call a foolproof way to find the factors of numbers, and I'm going to use my trusty calculator. You have a calculator on your Chromebook, you have one on your phone, you could use whatever is convenient for you at the moment. But here's what we do. We're going to start with dividing the number given by 1. 90 divided by 1 is 90. That is my first set of factors for the number 90. Now I'm going to take 90 and I'm going to divide it by the next number, which would be 2. 90 divided by 2 is 45. I'll go to the next number, 3. 90 divided by 3 is 30. Now it's going to get a little crazy, so I'm going to use my calculator. And I'm going to do 90 divided by 4. Get a decimal. Because I get a decimal, I don't want to use that. I want only integers when I'm listing factors. So I'll do 90 divided by 5, the next number up, and I get 18. So 5 and 18 is another set of factors for 90. Take 90 and divide it by 6, the next number up. Ooh, that one works too. 6 and 15. And I take 90 and I'm going to divide it by 7. I get a decimal, so I don't want to use that. I'll try the next number, which is 8. Again, a decimal. I don't want to use that. 90 divided by 9 is 10. Oh, and then the next number that I would try is 10, but since I've already used it, I know that I have successfully listed all of the factors. Okay, I'm going to have you try that for 16 and 40 on your own, and we will list the factors of 48 together. So 48 divided by 1 is 48. 48 divided by 2 is 24. 48 divided by 3 is 16. 48 divided by 4 is 12. 5 does not work out evenly. 6 and 8. 48 divided by 7, that would give me a decimal, and I've already used 8, so I'm complete with listing my factors. Okay? Now, I want you to do these two on your own, and then once you finish that, I want you to go through and circle all of the perfect squares in your factor lists. So I'm going to go to this one. I've got 1, I've got 9, and that's it. And over here I have 1, I have 4 is a perfect square, 16, and that's it. Okay, now the reason why we're using perfect squares is because we are going to simplify radicals. And in order to do that, we need to know our perfect squares. So we're going to take 90, which we listed the factors over here, and what we're going to do is break it into 2 separate radicals. Okay, it's similar to what we did up here. We want to find a perfect square that we can divide 90 by, and we don't want any perfect square. We want the largest perfect square that we can divide 90 by. So we've already circled the perfect squares over here, and we look at which one is larger. 9 is definitely larger than 1, which means we're going to use this set of factors for 90. And we're going to take those factors, put the perfect square first, and the other factor next to it. Now, the reason why I put the perfect square first is because this one is going to break free. The square root of 9 is equivalent to 3. So that one breaks free, becomes 3, and radical 10 stays the same. And very simply, we have simplified this radical. Okay, so let's try it for 48. Same thing. You're going to break 48 into the square root of 48 into 2 separate radicals. Now we're going to look at our list, see what the largest perfect square was that we used. In this case, it's 16, which means 3 and 16 is the set of factors that we're going to use. So 16 times 3 is 48. And please note, again, I put the perfect square first. Perfect child always goes first. Okay, and that's because this one breaks free. The square root of 16 is equivalent to 4, and radical 3 stays the same. And that's it. You've simplified the radical. Seems simple. As long as you use this foolproof method to list your factors and always use the largest perfect square that you've divided by, you should find success. So let's flip over and check out some of the examples on this page. So now, first thing, I want you to list the perfect squares. Try not to look back at the other page. Try to use your memory or your mental math to fill this in. And let's talk about simplifying some radicals with some other things thrown in here. So this one was done for us. It's just an example so you could see clearly the largest perfect square that you could divide 162 by was 81. And 81 times 2 is 162. 81 breaks down. The square root of 81 is 9, and the square root of 2 remains the same. So now let's try that for 20. Well, we don't know what the largest perfect square is that we can divide it by, so we're going to start with listing the factors of 20. So 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 3 is a decimal, no bueno. 20 divided by 4 is 5, and the next number we would try is 5. Since we've already used it, we know we listed all the factors. So now I circle my perfect squares. I've got 1 and 4, and figure out that the largest one was 4, which means we're going to use the pair 4 and 5 to break up this radical. Separate it into 2. Perfect square goes first, and its partner second. And now the square root of 4 will be to 2, and radical 5 remains the same. Please try this one on your own. And in the meantime, I'm going to come over to the square root of negative 90. Now we have a negative here. Do not let this scare you. All this means is negative 1 times the square root of 90. So I'm going to go back for the sake of time because we've already done that example. And we used square root of 9, square root of 10. So I break this one into 2, square root of 9, square root of 10. And all I do with this negative 1 is keep bringing it down because we're going to multiply it at the end. Square root of 9 is 3. Radical 10 stays the same. And again, I bring down that negative in front and multiply it. So my final answer should read -3 radical 10. Now try that with this one. Also do this one just for fun because it's such a large number. Okay, and I'm going to bring you down to these two where we have a coefficient in front. Having a coefficient in front is very similar to having that negative in front. All it means is that we're going to bring it down and multiply it at the end. So for instance, let's start with 45. We need the factors of 45. So we have 1 and 45. We have 3 and 15. We have 5 and 9. And I believe that's it. So my perfect squares are 1 and 9. The larger one is 9, which means I'm going to use 5 and 9 as my factors. I break it into 2. 9 was the perfect square, so it goes first. 5 goes here. We're going to bring down that 4 and remember to multiply, but not yet because we can simplify square root of 9. The square root of 9 is 3. Radical 5 stays the same, and we're going to bring down that 4 again and multiply. 4 times 3 is 12. Radical 5, final answer. Okay? Same thing over here. You're multiplying by 1/2. So you're going to find the factors of 32. 1 and 32, 2 and 16. Can't do 3, 4 and 8. Can't do 5, 6, or 7. So I'm done. My perfect squares are 1, 4, and 16. The largest one we used was 16, so we're going to use the set of 2 and 16 to simplify the square root of 32. So we break it into 2. The perfect square goes first, and its partner goes second. The 1/2 is just going to keep coming down until the end. Square root of 16 breaks free. That's going to be 4. Square root of 2 stays the same, and we bring down that 1/2, and we do what with it? That's right, multiply. 1/2 times 4 is 2, radical 2, and we've done it. Okay? So these three might look like they're a little tricky, but over here, it's just a -2 that you're going to take down at the end and multiply. When you have your radical over a number, it's just saying divide. So really, this is the same thing as multiplying by 1/3. And over here, you have a negative and a number underneath, which really just means to multiply by -1 over 16. Okay, we don't want that to scare you. Just push through, multiply by these numbers at the end, and you should be all set. So you're going to try the bottom 3 as well. Okay, and we're going to flip over one more time because I just want to show you an example for multiplying radicals. Okay, this one you should be able to do very simply. This one might look a little crazy. It says multiply 2 square root of 8 times 3 square root of 6. So what you're going to do in this case are your coefficients, 2 times 3, which will give you 6, and then multiply what's underneath the radicals. So 8 times 6, which will give you 48. And from there, you should know what to do. Okay, so we're going to leave that up to you. This one, same exact thing, but when there's no number in front, you should know that it's a 1. Just like if you had an X with no coefficient, there's a hidden 1 in front. Okay, so we want you to finish up to this page as well. If you have any questions, you know how to reach us. Good luck. See you soon.